Between the National Center for Scientific Research in France and Saint-Gobain. So as Alessandro says, it is an international material company. So the purpose of my talk today is simply to show you how I use Python to do segmentation on 3D images. And so segmentation, what is segmentation? It is when you want the computer to be able to discriminate automatically between two or more objects. So for example, between the white object here and the blue object here. I give you a little bit of scientific context. So in our lab, we have this glass here. That it is the barium borosilicate glass. And at high temperature, it is obviously melted and homogeneous. And then when you have the temperature colder, then you start to see two different phases. So what is a phase? You can represent in your head the oil and vinegar phenomenon that we all know. So when you mix the oil in the vinegar, you have the little drops of the oil inside the vinegar. So you can see the two phases in your mix. So we see exactly the same here in this glass. And so yeah, when we were looking at this phenomenon, we wanted to know more because we were thinking that maybe we can use this in our industry for our glass. We were thinking that if we can understand how this phenomenon works, so that means we'll be able to control the shape of the two faces, and we could do nanotexture on the surface of the glass. So one application is to make hydrophobic glass. So it's imitating the water lily, what's the name? Water lily leaf, as you can see on the picture here. So here we are with the glass and our questions. We took some samples of it and we went to the synchrotron in Grenoble. We make some pre-processing on the 3D images and then the processing and segmentation that I will talk in the following slides. Then we could do statistics and answer some of our questions and obviously have other questions. So I'll talk a bit about data acquisition because as some people may know here, in image processing, the better is the data acquisition, the easier it is to process the data afterwards. So we went to the synchrotron in Grenoble and we did 3D imaging using the X-ray tomography technique. So it's a non-destructive method, so that means you can see inside your sample without having to destroy it, which is quite cool. And plus you have access to the fourth dimension, because so, for example, in our case, we were taking 3D pictures of our sample every 3 minutes, so we have the evolution of our sample through time. Plus, we were using state-of-art technology. We were making those 3D images at 900 degrees and at nanometric resolution. So we were pushing the boundaries of the technique. So this is the data, the results that we got. So this is the data. I'll show you a little movie here. So you see the evolution over time of the two faces in the glass sample. So the sample is a cylinder, and this is a horizontal cut. And so we wanted to, we can see the coursing of the white face, so that means it's like in the oil and vinegar again. The system is trying to have its surface energy as low as possible. So it's like the oil, when you leave in peace the mix in the oil and vinegar, then you have the oil at the top of the mix. so that the surface of the system is the smallest. So it's happening the same, and we wanted to be able to characterize this system, so to know more about the volume of the white phase and the black phase, the number of the objects, the surface also of the white and the black phase, etc. So to do that, so this is the goal. So this is the segmentation we want to have. So here the computer is able to identify the white phase with the yellow contouring that you can see here. So this is the segmentation. How did we do that? So we started from the raw image that you can see here. So there was some remaining noise. So first we wanted to trying to decrease this remaining noise. I tested different filters, and the median one from SciPy was pretty good at doing the job. So this is before, this is after, before, after. So you can see that I deleted this circle noise, circle shape noise here, before, after. So what it does is that it computes the median of the voxel in a given window. So we want the window to be smaller as than the white shape. And then the value of the central voxel in the window, it is replaced by the medium value. So here on this graph, you see the results. So it's a histogram of the gray value, of the image, and the blue curve, it is before the filter, and the orange line, it's after. So what we did here basically is that we increased the contrast of the image so that we have, because what we want is at the end we want the voxel from the white phase to be equal to 1, and the voxels from the black phase to be equal to 0, so that we have a binary image and we can use it. So here we are on the good track, because we increased the voxels with the value 1 and the voxel with value 0. And we could do now just a threshold here, and saying, okay, all the voxels that are above this threshold will have the value 0, and all the voxels that are below this threshold will have the value, it's the contrary, well, 1 and 0. And so this is the global segmentation, actually. So we tested it, and we were not happy with the results, so we tried other segmentation module from Python. And one which was working well is the local thresholding. So because our image has shades, for example, this area is a bit darker in general than this area here, which is a bit lighter. So this is why the global thresholding was not working well, and the local one was doing a good job. So we were happy with these results. And now I'll show you the 3D visualization of it. So I used Mayavi, and particularly I used the contour grid plane and the sync trait. So it's thanks to that I can synchronize the result of my segmentation with the raw image. So here it's the 3D visualization. It is a good tool, great tool to qualitatively check the segmentation and have a sense of what we're doing and of our sample. So here we are inside the sample. It's just a little portion. So yeah, we were happy with the segmentation. We can see also some limits of it. Like sometimes the human eyes would say, okay, those two faces are not connected, and the segmentation I chose say, yeah, well, they are connected. So then it's a compromise to do between the quality of the segmentation you do and calculation time. So about the calculation time, I give you some numbers. So this is one sample, and as I told you, I have different 3D pictures of this one sample, and I have actually 80 3D pictures, so 80 volumes. One volume it is 1.8 billion voxels, so this is 7 gigabytes, totaling 560 gigabytes. So to do it quite quickly, I used Parallel from JobLeap, and it was really convenient to use because from my little job that I made to test on some slices, I could go for the whole production very easily with the Parallel. And so I divided my volume in 50 chunks with an overlap of 10 slices, and I used 30 cores of my machine. And thanks to that, I could have the running time at 17 hours. And I was okay with that because it was roughly a big night. And yeah, so I didn't want to spend more time to try to optimize because this, for me, this was enough. So then, we had this segmentation, and then we could start to do some statistics with it. So we needed the surface of the white face. So here it's a 3D representation. So again, to have to check what I was doing with the surface module, so which is the matching cubes Lewiner from SkyImage. And then the representation in Mayavi is a triangular mesh. And here you'll see a movie of this meshing. So it's only one part of my sample because it's a lot of data, and even if with my computer I couldn't load it everything at the same time, it was too slow to play with. And it's also at the edge of my volume, so that I can see how the surface meshing it is, how it the shape of it, if it works well. Sorry, at the edge of the cylinder. Then I calculated also some labeling to be able to do my statistics, to have the numbers, the number of my objects. And thanks to all of this, I could do science. And so I will finish with this cool view. So thanks to Python, also you can do 4D visualization. So this is my volume, just a little part of it in 3D. And then we will see that the shape will evolve through time. And this is, it was useful for us to try to spot some topological events. So this is 3 minutes later, 3 minutes later, and 3 minutes later again. So it's great if you need to see the evolution of the shape that you are studying. So yeah, I'll conclude with this presentation. So what you can take home is that if you're doing image processing, first it's always better to start simple, and then you can have a more complex algorithm if it's needed. But first, always try the simplest modules. Then in image processing, we have a lot of data. I forgot to say, but actually I had in total 1 terabyte of data to play with. So it's always, when you have such an amount of data, it's always a compromise to do between the quality of the segmentation, in this case, of the process you're running, and the time you have. Plus, Python is really good to use the simple thanks to Python, you can have simple and powerful tools. So the 3D visualization was really useful to do qualitative checks. And also, as I told you earlier, the parallel job was also, parallel module was also really efficient to go from the my test phase to the production phase. I'd be happy to share more details or the codes if you need them for your work and ideas. Also, if you have some, this is my contacts, and it's just a wink to Python because, as you may know, it comes from Monty Python, the name. Yeah, that's it. Thank you very much for your attention.
There was one burning question before we go to lunch.
So you used like a local OSU method
Mm-hmm.
to do that, and what was the size of your window?
Oh yeah, so the size of the window for my local OTSU method for the segmentation, actually it was evolving through time because the shape of my white faces was growing, so I had to adapt this window through time. Yeah. So I had to do different tests to see it.
Thank you.
Thank you.